Good morning to one and all. Today we are discussing liquid fuels. So in previous class we are discussing introduction to fuels, classification of fuels, chemical fuels, and classification of coal, solid fuels. So analysis of coal. So approximate analysis, ultimate analysis. We are discussing in the previous class. So today we are discussing liquid fuels. Liquid fuels are the important commercial and domestic fuels used in our daily life. Most of these fuels are obtained from naturally occurring petroleum or crude oil. So these petroleum or crude oil is called as a primary fuels. See, the previous class we are discussing types of fuels according to the occurrence and state of aggregation. The fuels are classified into two types. One is primary fuel, is also called natural fuels. The second one is called secondary fuels or artificial fuels. So this is liquid fuels we are studying. Crude oil is called primary fuel. So let's see what are the advantages of liquid fuels. So fuels we are using for our daily usage, domestic purpose, or commercial purpose. Industries may also using fuels. Some of the nuclear power plants, so thermal power plants, hydroelectrical power plants, they're utilizing fuels to generate the electricity. So that's why the fuels having a greater value in the nature, in the society. In previous class we discussed qualities of a fuel. There is good characteristics, good qualities of a fuel. Here we discuss the liquid fuels. So, and there are advantages. What are the advantages? Let's see the advantages of liquid fuels. So these liquid fuels may have higher calorific value when comparing to the solid fuels. When comparing to the solid fuels, liquid fuels may having the higher calorific value. While burning the liquid fuels, the liquid fuels which liberate complete heat energy. So because while burning the liquid fuels without dust, has, etc., that's why the fuel completely burn. They liberate energy. So their firing is easier, and also fire can be exhausted easily by stopping liquid fuel supply. In previous class we discussing we cannot control while burning the solid fuels. So here easily to control the liquid fuels while burning. So they are easy to transport through the pipes. They can be stored indefinitely without any loss. So there is no way of, you say, loss of liquid fuels while storing. So that is indefinitely without any loss while storage. So they are clean in use and economic to handle. So loss of heat in the chimneys are very low due to the greater cleanness. They require less excess of air for complete combustion. They require less furnace space for combustion. So these are the some major advantages of liquid fuels. Next we discuss disadvantages of liquid fuels. The cost of liquid fuels is relatively much higher as comparing to the solid fuels. The cost of the liquid fuels is higher than the solid fuels. So costly liquid fuels, especially storage tanks, are required for storing liquid fuels. A variety or a quality or special tanks are required for storage of a liquid fuels. So this is one of the disadvantages when comparing to the solid fuels. So there is a greater risk of fire hazards, particularly in case of highly inflammable and volatile liquid fuels we are using. So such type of fuels may face some risks. So these liquid fuels, they produce some bad odors and they produce some toxic gases into the environment or into the atmosphere. These toxic gases are harmful to all the living organisms in the earth crust, the earth surface or the earth surface. So for efficient burning of liquid fuels, especially constructive burners and sprayers we use. So these are the some disadvantages of liquid fuels while we using. So next we go for petroleum or crude oil. So petroleum or crude oil. So how we get crude oil or petroleum? So here one of the method called mining process. So mining process we get a petroleum. So let's see what is crude oil. The crude oil or petroleum. So the crude oil or petroleum is derived from Latin word. In Latin word, petra, that means rock, and oleum means oil. So it is known as a crude oil or mineral oil or petroleum is the main source of the liquid fuels. Petroleum is a main source of liquid fuels. So it is a dark colored liquid found well deep in the earth crust. So mainly the petroleum composed of hydrocarbons, which may be solids or liquids or gases, whatever it may be. So some optically active compounds having sulfur, nitrogen also present. So on the average, the composition of petroleum is carbon may containing 79.5 to 87.1% carbon present in the petroleum. Hydrogen may be present 11.5 to 14.8%. Sulfur may containing 0.1 to 3.5%. Nitrogen and oxygen may containing 0.1 to 0.5% in the petroleum. So next, refining of petroleum. So crude oil obtained from the mine. So during the mining process, mining operation, petroleum is brought to the surface by drilling holes up to the oil bearing area and sinking pipes into it. So generally, oil is pushed out due to hydrostatic pressure of natural gas. When the pressure of natural gas is not sufficient, then air pressure is applied through the holes, and we lifted the oil into to the surface from the well. So further purification processes, we get different oils or gases at different boiling points. So coming to here, refining of petroleum is obtained from the mine is not fit to be marketed. So that is they may having several impurities, soluble, insoluble impurities. So before we introduce it to the market, we remove all the impurities in the crude oil. So that's why we are using some of the methods for purification of petroleum or crude oil. The best method we use fractional distillation for purification of petroleum. So we get various oils at various boiling temperatures. So let's see the definition of refining of petroleum. The process by which the petroleum is made free of impurities, followed by the separation of petroleum into different fractions having different boiling points. And the further treatment to improve the specific properties can be called as a refining of petroleum. So that means we remove the impurities to allow the separation of petroleum into different fractions having different boiling points. So for the treatment, we get different oils at different boiling temperatures, and we can use it for our different beneficial or economical domestic or industry purpose. So let's see the various stages during the refining of petroleum is given here. Removal of solid impurities, removal of water, removal of harmful impurities, and we get fractional distillation. Finally, we get pure petroleums. So let's see the first one, removal of solid impurities. The crude oil may having n number of mixture of solids, liquids, and gases as impurity substances. So these crude oil allowed to stand for some time till all the heavy solid particles are settled down and some of the gases are get evaporated. So further, we centrifuge the crude oil, we separate or remove the solids. So next we go for a removal of water by controls process. So we getting crude oil from the earth crust automatically, they may having moisture, that means water levels. So in this emulsion form, the water in the form of emulsion of oil and brine. So we used the charged electrodes to destroy the emulsion films on the crude oil. The water droplets are formed as a bigger water droplets and separated from the oil with the help of charged electrodes. So next one is removal of harmful impurities. In order to remove sulfur compounds in the crude oil, it is treated with a copper dioxide, sorry, copper oxides. When we use copper oxides, treated the crude oil, they forms as a copper sulfide, and we remove by filtration substances like sodium chloride, magnesium chloride. We use it to remove sulfur in the crude oil by dehydration or electric desalting methods or techniques. So next we go for the most important one, fractional distillation. So this setup, fractional distillation, so they may having this small block lined dark block line pot is called as iron rotor, also known as furnace. So here we introduce crude oil to the mobile furnace, and the crude oil will passes through the fractionating column. So these fractionating column is a tall cylindrical tower. These tall cylindrical tower may called a fractionating column. So these tall cylindrical tower may having stainless steel tray at a short distance. So the horizontal stainless steel trays are having the fractionating column at short distances. So these stainless steel horizontal tray may having the chimney. So this is called a chimney with a loose cap. This is a loose cap. Here we insert crude oil into the iron rotor and we maintaining about more than 400 degrees Celsius as a temperature. The crude oil get boiled or heated and they move from bottom to the top of the fractionating column or cylindrical tower. So bottom of the fractionating column or cylindrical tower may having higher boiling points. When move to the top of the cylindrical tower, here may having low boiling temperatures. So while the crude oil when move from bottom to top of the cylindrical tower, the temperature, that means the boiling points are variation from one fractionating column to another fractionating column. At a different fractionating columns, the oil get condensed and they release from different trays. What happened? Let's see. Here we maintaining more than 400 degrees Celsius as a temperature. The oil get heated, boiled, then they move from bottom to top. So at the top of the cylindrical tower, may having below 30 degrees Celsius the temperature, that means low temperature. At the low temperature, we get the condensed gases. These gases we are using domestic and industrial purpose. So these gases may having the C12, C4 as a carbon composition. Next, we get petroleum ether at 42 1 we get petroleum ether at 30 to 70 degrees Celsius temperature. So petroleum ether we use as a solvent. So these petroleum ether may having the carbon composition C3 to C7. So then similarly we get gasoline or petrol at 40 to 120 degrees Celsius as a temperature. Here at the 40 to 120 boiling point, we get gasoline or petrol. We use as a fuel for motor vehicles and solvent. Petrol we use as a solvent and dry cleanings. So next we get naphthalene at 120 degrees Celsius to 180 degrees Celsius. So these may having C9 to C10 as a carbon composition, and these we can use as a solvent and also we can use it in dry cleanings. So next we get kerosene oil at 180 to 250 degrees Celsius as a temperature. This kerosene oil may having C10 to C16 as a carbon composition. We use it as a fuel for stoves. Next we get diesel oil at 250 degrees Celsius to 320 degrees Celsius. So this diesel oil may having the C15 to C18 as a carbon composition, which is used as a fuel for diesel engines. Next we get heavy oils at 320 degrees Celsius to 400 degrees Celsius. These heavy oils may having the carbon composition as a C17 to C30 carbon composition. So further purification process of a heavy oil, we get lubricating oils used as lubricants. Petroleum jelly, we get further purification, we use as a cosmetics and medicines, petroleum jelly. So we get grease as a lubricant. So finally, we get paraffin wax in candles. We use candles, wood polish and wax papers for the purification of heavy oils. So these are the boiling points, composition and uses where will be used the liberated gases from the fractionating column. So we are discussing today liquid fuels. Thank you.